So, September the 2nd, Volume 2, Number 1, 1991. Grassroots Science. The organisation of science as we know it has become increasingly professional and institutional, and big science is increasing in its scope and power, so that more of physics research gets directed into huge projects like the super accelerator. A lot of physicists are very worried because this is drawing off billions of dollars in funding. In biology, the conception of the Human Genome Project was brought about by a scientific politician who thought, well, if physics can have big science and military can, like Star Wars, why can't biology? So this was a deliberate attempt to model biological research on these huge projects involving billions in funding. And this project is going ahead. It's meant that there's even greater predominance of funding in the billions for molecular biology, gene sequencing, gene cloning, biotechnology, that kind of research. And inevitably this attracts funds, prestige and manpower away from the more traditional low expense, low prestige branches of biology. And this tendency towards big science and bigger centres and the predominance of fewer centres of excellence is going on all the time. The editor of Nature told me last year when I met him that there was a tendency for papers now coming from smaller institutions to be rejected, because the peer review process meant that people would say, well, why didn't you do a mass spectrograph on that compound? Why didn't you do this or that? Requiring, as part of the routine production of papers, the use of expensive equipment to which few have access. And he said that although the papers may have been of equal merit, the standards were changing in favour of large institutions and large laboratories. And so I said, well, what happens if you raise this question with the people who insist on these standards? Isn't it unfair on people in smaller institutions with lower access to big funds? And he said, not really. He said, if they're any good, they'll move to a big institution. So there was this tendency for not only increasing specialization, but increasing predominance of a smaller number of institutions and access to big money is coming to dominate the whole structure of science as we know it. And this is merely a carrying further of the process of professionalization and institutionalization that's overtaken mainstream science, essentially in the present century. In the 19th century and in the 18th, and indeed until the present century, the situation was very different. In Darwin's case, for example, he himself never held an academic post in any institution. And when one reads books like The Variation of Animals and Plants Under Domestication, the research base on which he was drawing was that of practical plant breeders, animal husbandry people, hands-on animal breeders, animal trainers, amateur pigeon fanciers, colonial administrators who'd observed what native people did, shipwrecked mariners who had stories about feral animals on remote islands, and so on. In other words, there was a vast wealth of knowledge that fed into Darwin's kind of science, hardly any of which came out of government-funded scientific institutions. Most of it was low-cost, grassroots type of research. It doesn't mean to say that the people didn't know what they were talking about. These were true experts in the sense that they'd spent many years doing what they did and spoke from a wealth of experience. But we see a completely different picture there. And what's happened is that the amateur and the non-professional base of science has become increasingly marginalized from the point of view of institutional science. You can't do research till you've got a PhD. You can't do it unless you're in a big institution. You can't do it unless you've got a grant. You can't publish it unless you can write and do the kind of thing that passes peer review committees, and so forth. Well, the tendency has gone further and further in this direction. So the question is, do things have to be as they are now, or is there a new model possible? Well, I think a new model of science is not only possible, but desirable, and not only desirable, but necessary. Because on the one hand, there's a collapse of confidence in big science. There's a decline in public support for massive scientific projects. Genetic engineering is getting a very bad press. Embryo research and biotechnology excite more public fear than admiration. And the same is true of nuclear research, particle physics research, Star Wars research, and many other aspects of big science. One of the results of this is that the public esteem for science is declining. People blame the environmental crisis, nuclear pollution, ecological depletion, agribusiness, factory farming, chemicals in food, pesticide residues, toxic wastes. All these things are blamed fairly or unfairly on the scientific establishment. And so the constituency that supports science declines as a political voice, which means that governments seeking to make cuts, as they always do, as they have been for years in Britain now, find it's quite easy to cut science budgets, and it won't cause much loss of votes. In fact, it may even cause a slight gain in votes. They've just axed Britain's main nuclear physics facility, the Daresbury laboratory near Manchester, in which Britain led the world. The whole facility has just been axed. And there was, apart from scientists themselves who worked there and other people in the scientific community, scarcely any ripple of protest. They saved £2 million a year. So this, especially in Britain, this declining confidence in science and declining funding of science has led to a reduction in scientific morale. Fewer and fewer people want to study science in schools or go into it as graduate students. And there's a declining interest in large-scale professional institutional science. So the thing is entering a kind of crisis. Many scientists are very, very demoralized, and it looks as if the great golden days of the golden age of the 60s and 70s of endless expansion is over, perhaps forever. Well, in this context, a possible new approach to science becomes more feasible because it may be necessary simply for economic and political reasons. But I think it's desirable even if it weren't for the fact that large-scale science is entering a state of crisis. And the reason I've been thinking about this is because of my own experience with morphic resonance research. Since this is such an unorthodox theory, the theory of memory in nature, since it goes against the established paradigm or model of science, funding has been very hard to come by. And what's in fact become apparent is that holistic research of the kind that this involves is much cheaper than reductionist research. If you study whole systems, you usually need relatively small funds, but the smaller the thing you study, the bigger the apparatus and the more the funding. So when you get down to the most evanescent of nuclear particles, you need the largest of apparatus, miles across, costing many billions of dollars. So morphic resonance research has turned out to be cheap, indeed almost free in some cases, and much of the leading research has been done by students as projects. And this has made it clear to me that students who do every year tens of thousands of projects around the world are quite capable of doing leading-edge research. They are actually doing it in the realm of morphic resonance. But in no other sphere of mainstream science could one imagine students routinely or be playing a major role in the growth of knowledge in this way. It's also made it clear to me there's a lot of really interesting and important research projects can be done on very small budgets by students or even by amateurs outside the framework of institutional science. And the book I'm working on at the moment, which has made me think about these things, proposes 8 experiments, that any one of which could break our current paradigms, but which would be very cheap to do, and some could be done by almost anyone. For example, investigation of the sense of being stared at that we talked about previously. and which is the discussion in our book of trialogues. So I think the conditions are ripe for a new awakening, a new renaissance of research, a kind of more democratic kind of science where more people are empowered to take part. And when you think about it, the kind of base that Darwin drew on exists today, and even more so. There are tens of thousands of amateur plant breeders. There are amateur orchid growers and people who lavish care, attention and their own funding on breeding new kinds of orchids. There are rose societies, there are bamboo societies, organised in societies where people swap specimens, have a great deal of experience and knowledge of their various species of plants. And again, with animals, there are probably more pigeon fanciers, dog breeders, rabbit fanciers, and so on than ever before. The numbers run into the millions of people with a great deal of experience of breeding and raising these animals. There are people who train horses, dogs. There are falconers who train falcons, including new species recently domesticated, building up a great wealth of knowledge, which is all available through amateur networks and societies. There are anglers and hunters who get to know the species they hunt very well. There are old-style naturalists still around. There are amateurs tracking ecological change as a result of climatic and other factors, who can build up invaluable records. There are hundreds of thousands of millions of home computers giving statistical analysis power. Previously the preserve of big institutions with big mainframe computers, making this kind of sophisticated mathematical analysis available to almost anyone. There are hundreds of thousands of science graduates with a training in the professional background, not working as professional researchers, who could contribute to this. And there are already areas where almost all the research that goes on is in fact amateur. These are some. In addition, there's the whole realm of psychedelic experience, where professional research is very limited in scope, but amateur research has accumulated a wealth of knowledge and experience. There are amateur computer experts who have developed an enormous amount of experience. And I think that this base that already exists, at present almost completely disregarded by institutional science, provides the basis already in place, costing governments nothing, requiring no external funding, from which a new kind of grassroots science could arise. One way would be through extension of existing networks, possible building up of regional research networks. And the way I'd see it developing is that this other kind of science would not be seen as a rival to existing science, but in the end this could all be complementary to the professional science, the scientific establishment, and these two systems could cross-fertilize and influence each other, whereas now they proceed as if the other one hardly exists. So that's my idea about the possibility of a new kind of science.
Well, it sounds wonderful and very promising, and if this could simply happen as you've described it, then the decline of science could be reversed. Clever young people could be attracted, more and better information and understanding could be developed, and so on. And I certainly think that's desirable, although I share with many ordinary people the decline of confidence in science for the reasons you've described. The acceptance of a new model of science, of grassroots science, of major developments, let's say, given birth by amateur groups and so on, the acceptance of all this by the scientific establishment seems very unlikely somehow. The population of the scientific establishment would have to be totally swapped out with new young people coming in who had grown up in these new style groups, and of course that's a possibility. I worry though about how, this would have to evolve through a series of developments difficult to envision at this time. But I see a problem in the communication, the extension of the networks, the sharing of the results, and the replacement of the function of big science provided by publication in journals with peer review and so on. I hate the peer review process, but somehow the very growth of population, the growth of civilization, the growth of the scientific establishment means there's this immense amount of data that if it's not shared or made available or archived in libraries or something, nobody can access it, then it fails to achieve the goal of these discoveries. That's the problem. So I think the key to this development of a new model would be the development of a new model of a communication system for sharing the results of research. It won't be necessary, it won't be possible for each group of pigeon fanciers in South Burlington, Vermont or something to have a journal and newsletter or something like that, a regional newsletter. There would be too many newsletters to read. So I think the secret key to empower the success of this new development is the communications aspect of the computer revolution, the bulletin boards, the computer networks, and developments not yet really vision for the archiving and sharing of this kind of information in central electronic libraries. That would be the key. And until everyone could access the results of this research and easily sort of survey all what had been done in a certain area and find out about these new hybrids and so on, that the dream couldn't really become a reality. Maybe it requires further development in the archiving and sharing of electronic information in order to make this possible. How will the regional networks be organized and communicate with each other? It could be that the lack of a successful means of communication that way is the very reason that these big laboratories and big science has actually evolved. The governments have sensed, they have tried, they've experimented, and they've proved to their own satisfaction that the investment of the bucks in a big laboratory gives a bigger bang than in granting smaller sums to a large number of small laboratories. Certainly these groups will need grants, they'll need some support. You have to have some equipment. Inexpensive science still does cost, right?
Well, I mean, the thing is that if you take, say, pigeon fanciers, they already have journals. Pigeon Racing Weekly and so on. There are several in England on newsstands. They already have newsletters. None of them get grants. They buy their own pigeons, race them, maintain them, breed them. There's a system of competitions or prizes for successful winners of races, but the whole thing is completely self-financing. Now, the idea I had in mind was in cooperation with these different communities of researchers or practitioners who already exist, one would pose certain questions like, how do racing pigeons home? Now, I have my own ideas about how this could be tested. For example, by moving the loft from the pigeons, seeing if they can find the loft. This is one of the experiments in the book I'm writing. Well, this kind of question, when formulated, put out there in the racing pigeon new press and in the existing newsletters, might engage a certain number of people in wanting to do these experiments. The results would be fed in through these existing networks of information to others, and there would be a debate and other people perhaps take part, and the whole of this community could be engaged in certain kinds of research projects. Now, in relation to, say, amateur naturalists, a project that I'm trying to get going in London, where I live, in Hampstead, is that on Hampstead Heath there's several species of trees that are showing very advanced signs of dieback or actual death. The London plane tree is dying off all over London, which will totally affect the appearance of the city. Willow trees are in a bad way. Acacias are in a very bad way. some species are not quite so bad. And opinions, most people have hardly noticed. But those who have noticed have different opinions as to why this is so. We've had 2 or 3 years of drought. There are certain fungus diseases around. There's an enormous increase in ozone and atmospheric pollution due to increased car traffic in London, photochemical smogs. Which of these are affecting it? And as the greenhouse effect begins to bite, as the temperature changes, what kinds of changes will occur in forest ecosystems? There's nobody keeping records. The Heath authorities are busy rushing around mending the drains and sort of clearing the rubbish. The preservation societies are busy trying to stop people cutting things down and spoiling the heath by building new police radio towers on it and that kind of thing. But there's nobody at present keeping a year-by-year record of what's happening. So posing the questions is part of it. And if amateur naturalist groups had clearly posed questions like, is there a year-by-year change in the bird population, the tree population, which trees are suffering, which ones are doing better, we would have an enormous database gathered from different parts of the world, which would be of practical value. For example, in what do you do about global climate change if the greenhouse effect is really happening, which it seems to be. If the climate of Britain gets warmer and drier, for example, what kinds of trees should be planted on Hampstead Heath now, so that in 50 or 100 years' time, well within the lifetime of a tree planted today, there's a reasonable chance of them surviving, rather than the whole place being an ecological disaster zone. And this is a very small, I take this because it's a very small example, but there's a much bigger question. What kind of crops would grow in changing climate? What changes occur in existing forests and existing ecosystems? So it's not just a matter of enormous accumulation of data without any kind of... that's happening already. These amateur groups build up enormous data banks which they share through networks and newsletters already in place. But for a larger picture and for the asking of specific questions, there could be a system whereby these questions are fed through these local networks or formulated with the help of people within them. And there could be a vastly greater research effort going on than there is now. And I don't think it would necessarily require a big change in the present system. Some of them, I'm sure, are using computer networks already. Others have existing systems of information exchange, like newspapers, journals, commercially produced magazines, the rabbit fancier. There's all these things. Incredible number of specialized journals are actually published and are self-sustaining financially. So I think it's partly a question of formulating questions that are of a wider interest than the nuts and bolts questions asked within these existing groups or within groups that could come into being, and put these into a larger picture. And that, I think, is the way that the research could be coordinated somehow through particular kinds of questions.
Yes, well, if interesting questions came along from a central authority or an interesting amateur, as, for example, your forthcoming book, and this captured the attention, the imagination of groups worldwide, and then they accumulated their data pertinent to the question in standard form, readable by other groups, and so on, then a bigger picture, regional or global picture of certain phenomena, like the death of plane trees, could be developed. But it might need, in order to synthesize all of this information, a really large map, a computer graphic display, or something that would be 2 steps beyond the budget of these small groups. Maybe there would be a secondary network where the primary pigeon fanciers and so on, doing research with homing pigeons and moving them home. They would create their primary data stimulated by a certain question, and then the secondary groups would access the data from other centers in other countries and other continents and so on, try to test certain hypotheses about the rate of advance, the strength of the morphogenetic field, the distant effect, the speed of the effect, and so on. Probably for all this to happen, it would require a substantial motivation, because these amateur groups have habits. They're habits of the 19th century groups, their survival of the grassroots science of the past, and some kind of broadcasting of their results to central labs or secondary research groups trying to develop a larger picture, a global picture that's not part of their habit. So to make this transformation from their habit to a new mode would require some kind of compelling motivation. And I think that this mention of global environmental problems is touching on what may very well be the powerful motivation that would incline these groups to attain to a higher level of cooperativity among themselves on a global scale. That's really what's needed, is increasing the connectivity between these groups. As in a neural net, you increase the connectivity and then global patterns form. So I think in the context of this idea that bad news is good news, that the rapidly approaching environmental problems, I'm personally worried more about global cooling than global warming. But in any case, a global change is going to simulate a global response, I think. And that might be the way in which the revival of grassroots science takes its strongest motivation. What do you think, Terry?
Well, I'm as interested in the next person as in the reform of big science. The way I would choose to react to Rupert's statement is, rather than see it as actually a practical plan for the reform of science, to see it more as a proposal that can serve to show us what's wrong with science and how far off the track we've come. My questions would address 4 areas which all arise, I think, from the same problem that I see with it. First of all, instrumentality. The grassroots science, you called it 19th century, Ralph. Grassroots science can be done with rather tangible problems. But if you're interested in the neutrino output of the sun or something like this, instrumentalities of great cost are necessary. And I think that science has not only moved from the easy problems to the hard problems in its evolution over the past 1,000 years, it's also moved from the cheap problems to the expensive problems, and that it is now wedded to instrumentalities of such size and cost that even nations seem to need to band together. For instance, the Super Collider project or the proposed joint Soviet-Mars expedition. I don't think there's any way for grassroots science to finance and execute an expedition to Mars. So I've made 3 areas of concern. Instrumentality, meaning scientific instruments of great cost. Technology, the fact that science is the handmaiden of advanced product research, is what has given it such overwhelming sway over most of our lives. Science is not done in the spirit of Greek curiosity about the order of nature. Science is done to make money on a vast scale, and I dare say no funding would be forthcoming if there was no anticipated payback from that funding. So then that leads to capitalism. what is its role in the promotion of big science over small science, and how can the impulse to do pure science in the Greek style or the grassroots style somehow be unlocked from the demands of capitalism, which distort that impulse, so that we may spend hundreds of millions of dollars discovering whether certain chemicals that will go into a facial soap are allergenic or not, but we wouldn't allocate $100,000 to study a very basic and interesting question like how the pigeons home. And then fourthly, and along the same continuum, science has been appropriated by the military-industrial complex. And again, this would be very hard to see how it could be disentangled from that. So I see your proposal as not so much a proposal for the reform of science, but for the creation of a kind of parallel institution. We could almost call it the people's science, or science, hands-on science. And I'd just like to hear you address all these things. I mean, I'm all for the idea, but I think science has been vastly transformed from the simple impulse to understand the natural world around us into a kind of hellish marriage with capitalism, technology, enormous instruments, and the military-industrial complex, and that I've probably named some of the most overwhelming and monolithic forces in our society. How can we rescue Dame Science from the hands of such intractable foes of the Greek and original impulse to simply understand and appreciate the natural world?
Well, I think that part of the answer comes from the shift in paradigm, which is happening for a variety of reasons, independent, well, not independent, but seemingly independent of these political and economic ones, namely the move towards a more holistic model of science. And as I said earlier, the holistic research, where you look at whole systems, is much cheaper than analytical research where you look at smaller systems. You see, atomism, which is the philosophy that underlies reductionism, puts the greatest emphasis on the smallest possible things. Hence, the highest prestige attaches to superconducting supercolliders, which are the biggest pieces of apparatus you can make, because the smaller the thing, the bigger the apparatus. Now, if we as we are doing, undergo a shift of model, so that kind of science seems somewhat less interesting, then the emphasis would become on studying the properties of molecules, of crystals, at their own level, of cells, of organisms, of ecosystems. That kind of science, requiring enormous increase in instrumentation, which goes together with a reductionistic approach, would simply become less important, less relevant, less attractive. And that would in itself help to take care of the instrumental problem. You can see the same thing in medicine. If you have a medical research system that we've got now entirely in the service of mechanistic medicine, then the emphasis goes on new methods of biochemical diagnosis, genetic engineered diagnostic aids, high-tech scanning equipment, and so on. And no research money at all in most countries goes into looking at the effects of other holistic methods, which meanwhile flourish even in small towns around the Western world. All the different kinds of holistic approaches that go on. There's not really much effort to compare these approaches to see which works better than others. There are a few small-scale projects, but it's clear that the economics of the medical system, which at present are escalating costs, which mean the cost of insurance or the cost of socialised medicine in countries with it, like Britain, are constantly spiralling upwards, are provoking a whole crisis in the healthcare system. Now, for political reasons alone in Britain, there's an increasing willingness of, for economic reasons really, of politicians to consider the possibility of holistic medicine simply because it's cheaper. And if you can cut down on the costs of heart transfers, expensive scans and that kind of thing by people doing more meditation, taking a few homeopathic pills and that kind of thing, have acupuncture, this kind of thing could lead to far cheaper medical insurance. It could lead to a much cheaper and more comprehensive health service in countries that have comprehensive health services. And it would lead to a completely different kind of medical research. I mean, how, in this context, which would be very relevant to medical insurance companies, which already, in some cases, insure people with chiropractors, osteopaths, acupuncturists, and so on. One way of going about this on the grassroots method I've suggested would be simply a survey method, a systematic survey carried out by students or local communities, going round asking people what diseases they've had, how they think they've been cured, and how they rate the effectiveness of the different systems they've had. This is, in fact, the word-of-mouth method, is how one gets to know about things like acupuncture. You hear somebody said something, they say it's been cured by acupuncture. You go to them, someone's got a bad back. It's a chiropractor that cures it, not going into an advanced surgical ward. In some cases that works, but for most people, these systems, which are outside the purview of orthodox medicine and the AMA, are what work, and you hear about them by word of mouth. A more systematic approach, you see, would be systematically to survey people's experience. You have like a consumer report on these systems, and this could be done at any level of sophistication or depth. And if it worked in the West, then you could extend it to India, where these different systems, Ayurvedic, the Unani system of the Muslims, the homeopathic system, the Western system, traditional forms of spiritual healing, all coexist. And every Indian I talked to when I was living there had quite clear ideas about which one worked for which. For jaundice, you wouldn't go to a Western doctor because they were hopeless. You'd go to an Ayurvedic or a Hakim, a Unani Hakim, because they had good cures for jaundice. For acute illnesses, you'd go to Western doctors and get antibiotics. For skin, long-term chronic skin complaints, you'd go to homeopaths. For mental diseases, you'd go to temples or to some kind of faith healing thing in a dargah, a Muslim shrine. There's a wealth of knowledge there, which is nowhere codified, nowhere investigated, passed as part of an ongoing, continuously modified oral tradition. And so, in the realm of medical research too, I think this method could be applied quite cheaply and simply without instruments. It would in fact give one a method of estimating the effectiveness of instruments through high-tech medicine. So I think that as soon as you begin to look holistically at things, the need for large instruments disappears. And it may be that if we think differently about the need for missions to Mars, the need for Star Wars, the need for the Human Genome Project, and the need for large-scale nuclear physics projects in this new context may seem much less important, and hence the process you talked about, the need for these instrumentation would get less. Then when it comes to the power of capitalism, the military-industrial complex, again, the power of these things are changing. The interests of health insurance companies and the interests of national health systems are not working in favour necessarily of ever more expensive medicine. There are political forces working in different directions. With the end of the Cold War, the need for vast high-tech military spending projects is going to become harder to defend politically. And so I think that the situation is changing quite rapidly in all these respects.
Well, what you seem to be advocating is the collection, and correlation, and study of data as something which doesn't cost a lot of money and which can be done on home computers and transferred among self-organized networks of people. And I agree that probably the forward rush of big science has ignored a lot of areas, but there are, what do you say to the extraterrestrial planetologists, or to the astrophysicists, or to the molecular biologists? It seems there are large areas of science which have become so wedded to the need for instrumentalities of great cost that there is no way to do them without vast research programs and enormously expensive instruments. So what you're really focusing on, I think, is not so much a downsizing of science as a refocusing of it on the biological, medical, and sociological domain, as opposed to
highly warranted, but can this be done? It's extreme, the inertia of the other forms of science to tell the physicists that the exploration of matter will be halted, to tell the astrophysicists that the exploration of the galaxy will be halted, to tell the oceanographers that the exploration of the deep sea will be halted, is not entirely in the service of the original Greek impulse to understand nature. They're going to be told that anyway.
They are being told already in Britain. Nuclear physics has been shut down.
So there's a budget crisis, and even if popular support remained tremendous for subnuclear particle research, there would the budget crisis would make it impossible to continue in that line, even if everybody wanted to. Meanwhile, we have new crises. You see, this nuclear physics was response to urgent need in the military-industrial complex, as you pointed out. They needed this defense against aggression and so on. Now we have a new problem, and the defense departments of the various nations are going to have to do about-face and reorient themselves toward the real enemy now.
Well, when you were talking, for instance, about gathering and integrating temperatures on or climatological data on the die-off of trees in Britain, it occurred to me recently there's been a debate in the scientific community saying that all ground-based temperature observations have to be thrown out of the model, because only if you look down from space on an environment do you actually get data which is not contaminated by local effects. So in some cases it seems there's going to have to be a continued reliance on...
All right, we acknowledge that big science is going to continue to exist, but it's got to, first of all, economize. Secondly, reorient itself toward real problems, not only to maintain popular support, to maintain any support, maintain any population of scientists to do it. And thirdly, it's got to reintegrate with grassroots science because of economies and also because the information on that level is needed. I think that the new model for big science is going to be data banks together with scientific visualization strategies based on computer graphics, which, as you correctly implied, is expensive. The mission to planet Earth, the NASA proposal to monitor the temperature every move from satellites, will actually be very inexpensive compared to ground-based methods of collecting the same data. The problem is how to visualize it. And there we see groups working at the national laboratory level with enormous supercomputers that are way expensive, trying to devise ways to synthesize all this data and sort of get the picture. So I think the new challenge for big science will be, they'll still have maybe more moderate budgets, but they will have to be focused in big laboratories with big supercomputers and with huge disks holding all this accumulated data. I mean, mission to planet Earth will be broadcasting down from these satellites terabytes, terabytes per minute of information that has to go somewhere. And until that's figured out, which will be expensive, we can't have any, I don't think we'll really get the benefit from all this grassroots science, either what exists today or what would be developed in the future in response to some really exciting new questions proposed from a larger view of global planetary behavior. Certainly, the physical sciences have hogged more than their share of the national budgets for science. And as Rupert pointed out at the beginning, the growing tendency of biological science to imitate this bad strategy of the physical scientists in putting all their eggs in one basket with giant machines and fewer laboratories and journals and so on. This is a bad direction because it's a dead-end street. This actually represents the devolution of science, led at the most rapid possible rate by the physical scientists, the astronomers with their huge telescopes, and so on. The piece of the budget pie for science is shrinking. Even if it didn't, it would have to be reorganized so that a fair share went to medical, biological, and also social and environmental sciences. Then everyone's budget is still going to be too small. And to get the largest result from the fixed budget, I still think it'll be necessary to have some big science, big lab centers where the synthesis of all the information will be handled. Be the largest problem of science in the future is just to manage this enormous database. And the fact that the physical scientists have got their unjustified piece of the pie so far is, I think, because within their big budgets, which still aren't infinite, they've been able to produce a result because they don't have to deal with data banks that are of unmanageable size. They're studying simple systems, and within their budget they've been able to deliver a product, something that can be adapted by business for new high-tech commodities, gadgets, and consumer.
Well, maybe we should think of it as establishing a sort of parallel track of rehumanized science, but retain things like the Human Genome Project, which promises a much deeper understanding of human disease and genetic defects and this sort of thing. The other thing is, institutions expect a payoff on the investment they make in the people they train, and somehow they are going to have to be talked out of this payback, because big science has been the tent under which product development and that sort of thing has gone on, which has then led to the payback into the universities so that these laboratories could be endowed and so forth and so on. It's very hard to see how in the small science model it closes the loop and pays its own way. It has more the quality of the English squire or naturalist who carries out observations in his local area that are very interesting, but that only his private wealth allows him the luxury of doing this. How will it support itself? How will it be other than something in the hands of hobbyists and dilettantes?
Well, there are two things that could happen there. One is that well, already amateurs do these things on quite a large scale. Pigeon fanciers, of whom there are about 500,000 in Britain, are mostly working class, and some of them are on social security. The one I've worked with most closely can't work. He's got a disease. He's on social security. It's so cheap that you can do it on that level. This isn't just the province of squires. Maybe orchid growing is if you need greenhouses. But there are certain kinds of things which we live in a far more prosperous society than ever before. So that this kind of expenditure of your own money on what you really like is widely available. Many, many people take advantage of it, even if it's only at the level of gardening. And it's one of the most popular of all hobbies. People don't need grants to buy plants for their garden, and they wouldn't need grants to graft different ones together or to breed different ones by crossing them. We're using a camel hair brush to transfer the pollen from one to another. So plant breeding and things are so low budget, they're actually within the capacity of hundreds of thousands, of even millions of people already. When it comes to the need for additional funding for data banks, for things where you do need other things, I think that there could be a new system of, there could be regional research councils, there could be, there's various structures you can think of where a tiny fraction, 1%, 0.1% of existing science budgets were put in funding this grassroots science, together with a series of competitions. I in fact suggested one to the editor of Nature when he told me about this increasing complexity and cost of research as the tendency. I said, well, why not offer a $10,000 prize every year, the Nature Prize, for the best research conducted on a budget of less than £1,000? And he said, there's no point because no one would enter for it. And I said, I would. And he said, well, then I don't think we'll offer the prize. But the possibility, you see, I've found in my own experience that prizes act as quite a strong motivation for people. So in morphic resonance research, the most recent competition, the results have just been announced, for student projects, there was a $5,000 prize to be shared between 3 people. Worldwide. This motivated some very interesting research. And so a tiny fraction of existing science or education budgets devoted to funding this grassroots network would be politically popular, because it would be far more politically popular than the 99% devoted to big science and existing projects, because it would touch far more people and would give more visible results. Because the kind of budgets we're talking about are so small, a little amount of money would go a very long way. So I'm not saying it wouldn't need funding, but the amount of funding would be so small compared with existing science budgets, you'd hardly notice it, this deflection of a tiny percentage of existing budgets in this direction.
Yes, that's right.
Well, don't you think, though, that the public's support for science is based on the expectation that it will usher in new technologies, which the mass of people have a great faith that these new technologies will then deliver them into a somehow better world? And if you break that chain of expectations and say, no, well, we're now going to do science in such a way that you can forget about new technologies, that the interest in science will decline to the level of the interest in support of Tournament Go or something.
Of the old model, just think of, we're talking about the revolution of science in the context of a major paradigm shift in which it would be but one component. And one of the things we're anticipating in the future are these global environmental problems. They're already here. So people, I think, in the future are going to expect from science, from government, from religion, from themselves, the salvation from these serious problems. Just as now from medical science, they want the cure of cancer and AIDS.
Solutions.
They want a solution. They don't want products.
No, but they want solutions.
They want solutions. And in order for this to be forthcoming, for the grassroots science, for a science project to participate in the solution of these problems, I think it wouldn't suffice to develop a new and parallel scientific establishment living on its own and doing its best work on a low budget or something. We would want to integrate that with the new model for society, which would be emerging in order to, under the pressure of this evolutionary pressure of environmental problems. That means that the new science, grassroots science, would have to link up in an effective way with journals, with glossy magazines like Scientific American and so on, presenting the progress that they do make toward solutions of major problems, alongside the results of the big laboratories and everybody else. It's not enough to offer competitions and prizes. You must also offer the possibility of publication, access to the publication, which can garner the public support that nourishes amateur as well as professional scientists.
Well, take as a test case, and it's also a very real dilemma, the depletion of the ozone hole. To even study this requires the cooperation of air forces, massive data acquisition and analysis facilities. And when you move from studying it to doing something about it, it may take a significant portion of every dollar we all make for the rest of our lives. And the fate of the planet may hang in the balance. Now, how can a grassroots science make a contribution to that?
Because the ozone hole was first observed in a federal laboratory which had collected data that it neglected to study. So when amateur scientists would have had, if amateur scientists would have had access to the data sitting in this archive, then they might, and anyone with that access might have made the discovery of the ozone hole. In fact, the person who discovered it was the person who collected the data, but it was several years later. Also, the ozone hole was originally thought to be totally isolated over the poles, but now they've discovered this vortex mixing, that the ozone holes at the poles are gradually sucking ozone from the temperate regions. So if amateur scientists had ozone observers, which are a little telescope, simple device, look straight up, measure the ozone density over their own home, then it's just like the plane trees, the rate at which the ozone depletion is diffusing over the population centers would then be observed by amateur scientists, where it might very well be overlooked by the large laboratories that exclusively devote their research to these high-flying U-2s that go over the polar regions.
And to do something about it?
I could envision a new model in which big science existed as it is today on a lower budget. Grassroots science existed as it does today on a larger budget. And the two are coupled together much more tightly through information sharing mechanisms. The National Science Foundation, for example, in the United States might have as its main mission the storage and provision of access to this enormous data so that people can come with a new hypothesis, a new question, a small competition, stimulating high school students who could then actually obtain the data that no one is looking at about the ozone depletion or something else, and win the prize by making a phenomenal new discovery of data which maybe is sitting around and has been provided by some very expensive instrument. That's the combination.
So it seems to be, we keep returning to this thing, that the big science provides the data, or the data is accessible by non-expensive local means, but somehow the problem is to acquire the data. And for many, many problems, I mean, I mentioned the ozone hole. We could also talk about the danger of planetesimal impact on the Earth. Things like, or analyzing the effect of the Philippine volcanic eruption. Somehow the acquisition of this data sounds like it's going to keep big science in business for a while. And I absolutely agree with you, there should be no such thing as classified scientific data. That's an obscene concept. But I wonder if, at least at this stage in the technological revolution, a Mach 2 is sufficient to deal with the data collected. Perhaps it is. But if not, then the small scientist remains at a disadvantage, because number crunching is a part of the analysis of the huge data stream that is coming in. Maybe the answer is to concentrate on dropping the cost of supercomputing.
Well, that's happening.
But that would require an enormous governmental project costing billions of dollars and so forth and so on, the very thing we're trying to get away from here.
Well, I think the computer revolution is actually the answer to the main problem. The prices are spontaneously dropping. Supercomputer on the desk, the personal supercomputer, is a reality today. It'll be cheaper tomorrow, the Mach 3, the Mach 4, and so on. Let's take that for granted. I still think...
But it will be brought to us by Apple Corporation, one of the largest corporate entities in the American capitalist mix. It won't be done by two guys in a garage. That era is gone forever.
Not well. I mean, you're now concentrating on these huge, like the ozone hole problem, and how can you apply it? First of all, how the ozone hole, what do you do about it? A lot more was done about that, in Britain at least, by amateur groups like Greenpeace and Friends of the Earth. You know, people protesting to corporations about canisters. There's some protests about fridge recycling. These things, they gather data. They don't need huge number crunchers. You need fairly simple data to turn doing something about into political action through existing pressure groups. Secondly, the question of well, no, just leave it at that for the moment about the ozone hole. The second question about information gathering, there isn't in fact a glut of information in some areas. There's a great shortage. Friends of the Earth also collect samples downstream from industrial firms in rivers and from drinking water supplies, and find that in sort of 30% of Britain they exceed the nitrate levels permitted by British and EEC regulations. Pesticide residue levels are far too high, etc. Data which, if it's collected at all by our government, is kept secret, and which, when revealed and published, requiring no great sophistication of laboratories, no enormous number crunchers, can lead to enormous political knock-on effects, questions in Parliament, letters in newspapers, public protests, that can actually begin to do something about these things. So the environmental groups have already used fairly simple analytical techniques, fairly simple data processing methods to great effect. So the ozone hole is... You know, that's why I don't deny there's a problem at that level, but there are problems at much lower levels where an enormously greater amount could be done by amateur data collection without vast number crunchers, and where the translation into political effects, doing something about it, are much sooner and quicker than the solving of enormous global climate problems.
Well, so I think we're left with the conclusion that there has to be a parallelism, that somehow there's room for both of these approaches, that they address different areas of concern, and that when they can make common cause, that's all well and good, but that they're really directed toward, in most cases, different ends.
Well, not necessarily, you see, because coming back to an earlier point where you said that what people want in science is something that gives a product or something useful or some public good. That's not really always true in some cases, but think of the things that are some of the most popular things in the whole of science that interest even 3-year-olds, namely dinosaurs. Science museums draw millions of people to them if they put on displays of dinosaurs. Stephen Jay Gould sells millions of copies of his books, which are about things like dinosaurs, extinctions, and so on. The only form of popular science that interests Merlin, aged 3, is dinosaurs. He goes to halls of science to see dinosaurs. And so the interesting thing is that there's a kind of science here which has an enormous grassroots base, which has nothing to do with...
But a major paleontological project has the character of a major dam building or excavation project. I mean, it costs millions.
Most of these bones were collected in the last century by amateurs for virtually nothing. Well, it may cost millions to build these huge plastic models that emit roaring noises and are engineered to sort of...
Well, I'm talking about sinking a fossil shaft somewhere in the Gobi Desert and extracting in a proper scientific manner the fossils therein over 2 years requires maintaining hundreds of people in the field, from staff scientists down to coolies, and the air transport
about 50 cents a day.
And the air transport of hundreds of tons of rock.
It doesn't have to be air transport. I mean, paleontology was already a well-established science in the 19th century on incredibly low budgets, mostly funded by amateurs. It's a wonderful example of low-cost grassroots science.
Amateurs like Baron Guy de Rothschild.
But many others. There were many amateurs who have played a part in the development of paleontology, and it's one of the most low-cost areas of science. And it's one with one of the highest public appeals. So,
well, I don't have that great a familiarity with paleontology, but I think I do know something about archaeology, and it costs a fortune, archaeology, to do it right.
A lot of expeditions were done on a very low budget. For example, when Flinders Petrie first went to Egypt.
But I'm talking about today, when you go into Guatemala or the Yucatan to excavate a Mayan site, to keep a team in the rainforest for 6 months.
Well, Rupert hasn't suggested to slash all budgets to zero, and presumably these relatively expensive projects will continue to be funded according to the degree by which they can gain public support. They provide exciting results, solve important problems, and so on. They could be funded. Simultaneously, they could be influenced enormously by discoveries of the Grassroots Science group, feeding into the determination of how this budget is supposed to be spent.
Well,
yes,
we might stick with archaeology for a moment here, because it's an interesting science in that it doesn't generate new products. It doesn't give us a sense of progress. It doesn't feed into the military-industrial complex. It seems almost the model of what we're talking about, and yet it's absolutely famished for money for all those reasons, and finds it very difficult to obtain funding. An enormous amount of archaeology is funded by the patronage of wealthy enthusiasts, and it's not a happy experience to spend an evening with archaeologists listening to them discuss the difficulties they're having funding projects that they are in a few minutes able to convince you are very, very worthy and interesting. Archaeology is almost the paradigm of the small science enterprise that we're talking about, and yet it seems beset with difficulties that may show us problems that we can anticipate if we try to expand this model.
Well, I mean, at the moment, the archaeology budget, I'm sure, is a tiny fraction of 1% of the budget spent on the Genome Project, Star Wars. We're talking, the global archaeology budget must be, 10 million, 20 million, at most?
Something like that.
$50 million, I should imagine.
I should be
and this is absolute peanuts.
You might as well say it is an amateur science.
But it is an amateur science.
A lot of it is an amateur science, and then it's got this professional end where they have to raise funding, often from private concerns and so on, or wealthy donors. It is an amateur science. It has a large grassroots component even today. You know, people who excavate in an amateur manner. There are Anglo-Saxon excavations go on in Britain, for example, using students in the vacations, amateurs, and so on, with very minimal central funding from the government. And so archaeology is actually a case in point. It's the model. You've got a large grassroots base, a large grassroots popular interest, museums which can attract lots of people to see these things. And even the biggest projects are relatively cheap compared with large-scale science. What's happening now, you see, is that what this discussion is proposing is not that 100% of available funding should go to grassroots science and zero to existing institutional science, but rather to change the present situation where 100% goes to existing institutional science and 0% to the more grassroots mode. A shift in balance from 99% to institutional science and 1% to grassroots science would totally turn around the situation, change the popular base of science, its popular appeal, and I think bring a whole new vigour and a whole new spirit into this scientific endeavour. One further thing, which is your particular realm of expertise, psychedelic research. It seems to me a very important component of consciousness research. We hear a lot about the need for consciousness research. We know so little about the human mind. A lot of funding goes into cognitive psychology, particularly if it involves computer models, because it could feed into new generations of computer. That's why the funding goes into that area. Relatively low funding goes into psychological research that's to do with psychotherapy, because that's most of the province of practicing psychotherapists who are self-funding, or rather who are funded by the people that go to see them. A certain amount goes into official psychiatric and drug research to do with centrally active drugs. But the vast majority of psychedelic research, 99.999% at least, which has a lot to say, as I suppose you would agree, about the nature of consciousness, the range of the imagination, the powers of the human mind, etc., is not funded at all by official agencies. In fact, every effort is made to suppress it. Mm-hmm. In spite of official discouragement and suppression, where hundreds of millions of dollars are spent in trying to stop it happening, rather than encourage it, it actually goes on. And there's a wealth of experience built up about human consciousness, which is relevant to the larger question of the nature of our minds, their relation to our bodies, the relation of consciousness to the biochemical level, things which are perfectly compatible with a lot of mainstream concerns, and certainly of enormous interest in trying to get a better understanding of the world we live in and of ourselves. Here's an area where, for legal and other reasons, virtually the whole of the research effort is in the amateur domain, and virtually the whole of it is negatively funded rather than by the public domain, in the sense that funds are spent trying to stop it. Here's an area where there's the possibility of networks and of coordinated questions being asked, which could be of enormous value starting today, because there's not much prospect of this research being taken up officially. Yet there's, I would have thought, the formulation of appropriate questions could lead to very interesting research being undertaken by explorers of the psychedelic realm.
Yes, I quite agree. I mean, this would be an obvious area where the simple codification and making available of data would have a tremendous impact on the models being developed within the field.
There's a related area as astrology, or the so-called pseudosciences altogether. These are not going to be funded any other way than by amateur groups, I suppose. I think that if the means existed for sharing the information that already is known to result in various experiments.
So we do need to get out.
That a new sense of the pseudosciences with the regular sciences would result. For example, if people had a computer program that displayed when they woke up each morning their natal chart and the positions of the current planets, noted any transits of the daily planets over the sensitive points on their natal chart, and tried to correlate that with, for example, diseases, psychological states, and so on. Then there's a tremendous amount of information coming. There's thousands of people who do believe in astrology, could be available for high school researchers and so on, testing hypotheses posed from some other areas, such as archaeology, paleontology, and big science of planetary astronomy, for example, about possible impact of planetesimals and so on. All of this could be synthesized easily using computer network technology, according to some wild hypothesis that came in from some clever high school science teacher. So the psychedelic research, pseudosciences, other things that are totally rejected by society would have cracks in the structure through which they could reemerge back into the mainstream and making a contribution toward the solution of our global problems.
Yes, human sexuality would be another area where data is not gathered because of institutional biases that are conscious or unconscious, but that networks of amateurs could organize themselves. And this is probably largely how it's done anyway. It's probably one of the least organized areas of social research that exists. And yet it's central to the, our psychological health and our sense of equilibrium in the world. Nutrition is another.
Yes, that's a wonderful example of nutrition, because lots of people pay attention to what they eat. Official nutritional studies are on the whole pretty crass. I went into this when I was working in India. We were looking at the simple question of protein requirements. It turned out that the whole of the global food strategy had been based on studies done using American college students as average people. The protein requirement, based on a heavy consumption of hamburgers, something like 60 grams of protein a day. Well, this, as people widened the database, as people looked at what really happened in India to poor people, this has been lowered to about 20 grams a day. And yet the whole world food production strategy was distorted for 2 decades by this kind of nutritional study. Real nutritional research that looked into specialized areas like allergies and how to deal with them would have a large number of volunteers bringing forth information. Right. Research on people who can survive with incredibly little food would have enormous implications for the world food problem by showing that it may be possible not only to work on increasing the supply but reducing the demand. Because it may be possible, as some people practice doing, as part of spiritual disciplines or otherwise, to survive on incredibly small amounts. There's huge areas in nutritional research where there's a wealth of information that's totally untapped at the moment. The official nutritional journals are based on artificial experiments or nutritional surveys where people go around with clipboards or sit around observing people eating and noting and weighing them every week. We carried some out in India ourselves. Of a completely unrealistic kind. And yet, nobody thought of going around and asking people what they thought about nutrition.
So one of the faults of big science is associated with the reductionist perspective, I suppose, is this gradual, progressive, never-ending elimination, trimming, pruning off different things that are labeled as pseudosciences, amateur, fringe science, and
or subjective.
Subjective, all the paranormal, all the nutritional, all kind of alternative medical, all these things that are rejected comprise a daily growing group, while the number of natural phenomena studied by big science, official science, and establishment science is always shrinking. So one of the important gains of a new model for alternative science would be to open up cracks in the structure for the reintegration of all these different threads, which represents a kind of a holistic approach to the whole field of knowledge, especially when you include archaeology, history, the social sciences, and so on. What we're talking about is bigger than science, really. It's the reintegration of the entire local sphere.
Of research in general?
Yes.
Yes, because there's a great deal of amateur historical research goes on through local history societies and so on, which is, on the whole, unintegrated with professional endeavours. So that's one thing. I think one further thing that is worth considering is the formulation of questions. Now, I'm trying to do it in my book called 8 Experiments to Change the World, where I formulated 8 specific research areas with 8 specific experiments that could be done on very low budgets, any one of which would have a paradigm-shattering effect. Taken together, would reduce our present model of the world to rubble and require the adoption of a much larger and holistic view of reality. These would be, they're all things that can be done for budgets of $100 or less. Now, I've spent some years trying to think out this kind of experiment, and the ones I've finally come up with for this book are selected from about 20 or 30 that I've considered. But this is my own unaided efforts, and it's a virgin field, and I can't believe that I'm the only person capable of thinking of these things. There must be many people, given the incentive, who could think up really good questions. One thing that happened with morphic resonance research was a competition run by the New Scientist magazine for experimental designs for morphic resonance, with prizes totaling only £250, which led to a considerable wave of creativity in experimental design. In terms of large-scale questions, the kind of endeavour I've been engaged in thinking up simple experiments is something which groups of people, such as ourselves or such as exist in many parts of the world, could get together and think of questions, and not only think of the questions but think of ways in which they could be plausibly implemented on low budgets by groups of amateurs, actually work out questions and possible strategies that could be implemented. These would then be competitions one way, a kind of forum for questions in which these questions were published, and the most interesting ones would be taken up by others and stimulate a public debate is another. But this is an important component of it, and this is something that costs nothing. It just involves people sitting around thinking and talking. And this, I think, is a very important component of it, because there are lots of people in place who can do the experiments, but most people outside the scientific endeavour have not felt empowered to ask the kinds of questions which you can ask. And because my own background's in experimental science, I don't have that particular inhibition. But most people, once they get into the idea, at least a lot of people, when they get into the whole mode of thinking up questions for themselves, not feeling they can't ask them because they're not professional scientists, are quite capable of appreciating, understanding and asking these sorts of questions. So the realm of question formulation and experimental design in this context is a vast one, which is a wide open field, and which could lead to interesting debates, publications, letters. It could be done through existing popular science journals. If New Scientist or even Nature had a page in each issue devoted to the discussion of less than $1,000 research projects or things appropriate, small science corner. A question corner.
Every science journal should have a question corner.
That's right, and then readers' letters where people would write in and say, well, that design wouldn't work very well, it'd be better to do it this way. A whole debate could be started within international science journals themselves and things like Scientific American, New Scientist, which would have a great reader attraction potential and would cost virtually nothing and could exist within existing.
We need a magazine called Poor Scientific American.
Well, some journals already have a question corner, I suppose, like the Journal of Seriology. I think they're interested in posing questions.
That's right, and they also have people's predictions for the year, where people can offer their predictions about what's going to happen.
Next year's discoveries.
Yes. Well, something of this kind probably wouldn't survive actually as a separate journal, but as once this idea got more widespread, Within existing periodic, even newspapers could run on their science pages, and there could be sort of sections of this in schools and universities, student societies and so on. There could be, if there was some forum in which the questions could be aired, if some means by which they could be not merely sterile exercises in imagination, but rather have prizes or competitions that stimulate this and give a personal reward to those who think them up, and also some means by which the research can be implemented and fed into the amateur networks. Then we'd have a completely different model. Like in psychedelic research, you see, one could formulate particular questions which one could ask of people who take mushrooms or cannabis or whatever, DMT, and the various psychedelics, questions which would be which seem interesting or important to those experienced in the field, which could be asked of many people. People could write in to some address or through some newsletter or networks or something. This information could be collected. But formulating questions is an extremely important part of this whole vision and endeavour. And fortunately, that's the cheapest part of the whole thing.
As you know, mathematics, well, it's not a science, but it has this alternative structure already. It's always been very strongly influenced by questions and prize competitions. And the bulletin of the American Mathematical Society has a regular question corner, and students and all kind of amateurs send in their entries, attempted answers of these problems. Some of them are quite difficult.
So there's an existing model up and running.
Yes, which it does have a very strong stimulating effect on the whole development of the subject. And some of the best people are in charge of the question corner.
Yes, well, Scientific American, the amateur scientist section of that has
exposure
run for years, and some quite intricate experiments are carried out for very little money.
So we've already got models up and running.
Yes.
So how could all this be implemented?
Well, we have we sort of derived a workable alternative system. We're assuming that other paradigms in society would shift simultaneously, then this would naturally happen. I think the key just for example, on the integration of the different paradigm shifts, the key for the transformation into this new model would be changes in the universities and high schools. We mentioned several times high school students responding to these prize problems, and not so many times university students. Universities have been one of the main institutions supporting this restrictive, peer review, super professional, and archaic model of science. If universities were reformed so that they had departments of integration, as it were, interdisciplinary programs, and a holistic approach, then they could play a tremendous role, you see, in preparing people, educating people to be amateur scientists, for example, and interesting them in many of these problems. I mean, the questions being proposed by the question setters should become part of the curriculum in universities, for example. As morphic resonance research has penetrated universities a little bit. At the University, for example, that's a model that should be spread worldwide. Universities should be revitalized along with the revitalization of science and the creators. Like in physical education, so-called, some schools have team sports. You see, these are of no use whatsoever to the amateur athlete. Very few universities, like my university, the University of California at Santa Cruz, had no team sports and only individual sports because they wanted to prepare people for a new society. It was formed in the 1960s when in the hip subculture, everybody gave up team sports and wanted only individual sports, something that you could continue throughout your entire lifetime. So that's a kind of change which is wanted in universities and all their other structures, so that the full holistic range of intellectual endeavor, including what we call research, is nothing more than participation. The person who's going to participate in life, in evolution, in building the future of the planet and the species, then among other things it's necessary to do research. One should be an amateur athlete, an amateur scientist, an amateur historian, and so on. Everyone should throughout their lifetime. If universities are preparing people with a model of education, of self-education, which could be continued indefinitely, then of course they would be teaching this. They would be teaching grassroots science, where to find the questions, where to publish the answers, how to use the computer how to do it.
In a sense, the move in science teaching and other forms of teaching towards students doing projects, which has been something that's been going on for several years now, is working in this direction, because now students are taught to do projects, and a lot of the teaching is supposed to happen through projects. The only trouble is the projects they do are ones of the most utter banality and derivative kind for the most part, because it's not assumed that a student can really do a serious and interesting project of any wider interest. These are like juvenile training exercises for research rather than the real thing. And there's no doubt people need training in research methods, but there's very few student projects that I've ever come across are conceived of as being real research. Now, the morphic resonance ones are real research, and there may be other areas where they do real research in student projects, but the direction of training students to do projects is already in place. This is mainstream. It's just that taking seriously what's already mainstream hasn't happened yet.
Students are demanding more interesting problems if we set them. And because they're not set them, they abandon science and go to something else which is more interesting. And they have real problems that students can address, like the computer science. So the creation of a new model for science, for grassroots science, would actually give universities the opportunity to revitalize their science curriculum, thereby attracting once more the better students who are talented particularly for that, giving them something to aim at in their lifetime of research without large grants and working in big laboratories for the military-industrial complex. So I think it's this whole discussion bodes very good news for universities.
Good. Well, I think we've solved the problems of science.
But I think all people who have psychedelic trips and meditations and so on are poking more or less into the same higher realm and receiving some information from there. If we can develop this could be absorbed into ordinary science that we could approach with the scientific method and so on, then our intelligence, our capability of survival on planet Earth would be increased. I mean, we're a dying species. We live on a dying planet. We're killing the planet. So our disease is extremely serious. And therefore we're desperate to find new information, ideas, and so on that can transcend. We have to evolve. And I think our intellectual evolution may be predicated upon the psychedelic pioneers.